Right. So we got to agree on what our first minimal viable product would be, and we have an angle of attack and what feature set it might comprise of. So, cost. So what we're going to do basically is we're going to start with this number range first, so like a modified Fibonacci number range. And we're going to assign relative sizes to these features. And these sizes are a proxy basically for cost, but we'll talk more about that. So what number range are we going to use? We're going to use this following number range. It starts off with 1, 2, 3, 5, 8, 13, 20, 40, and 100. So why do we use this number range? This is also known as story point range. And well, let's see. And as you see, it's almost like the Fibonacci sequence, just not quite. So let's see, why do we do this? How do we go about using this number range? So first of all, you might be wondering is why don't we have the number 22 or the number 43? Well, basically this has to do with massive force economy, force simplicity, being able to move fast and stay with information that is relevant. Now, if we're talking about things we don't quite understand yet, we haven't got the time to argue about whether something is a 25 or a 26, or whether it's a 14 or 17 or 17.5. No, we've got this number range, and based upon the information we have now, this is in any case expressing increasing amounts of serious uncertainty. And we're not going to spend the time worrying about whether something is a 25 or a 28 or whatever the case may be. It's going to be a 20, or it's going to be a 40, or it's a 13, or it's 100. Because that is the right level of information detail at this point in time. Trying to do any more than that is sort of like trying to be precisely incorrect, which is of course silly, waste of time. So let's see how we apply this number range. And I've put together these sort of like circles and a couple of triangles and squares and so forth. And how it starts is we take one of these items, which we think is quite a small one, and we give it a size of 2. So let's call this one a 2. And I hope you can see reasonably well for me to get the idea across. So if this one is a 2, well, this one might be a 3. It seems to be a little bit larger. Not much, but a bit larger, so maybe it's a 3. And, you know, this one seems to be, again, quite a bit larger than that one. So if that's a 3, maybe this is roughly a 5. And if this is roughly a 5, then that is probably going to be an 8. So we can only pick from this number range. So it's a relative. So this one relative to this one is probably about 4 times as big. And yeah, well, it seems to be reasonable. So take that side, and it's got about 4 and about 4. So yeah, looks about, you know, roughly an 8. And we're not going to argue whether it's a 7 or a 9, well, it's an 8, roughly an 8, and that's good enough. And if we go further, maybe if this one is roughly an 8, maybe this one is roughly a 13. This square over here is probably roughly a 20. And yeah, I think so roughly a 20. And, you know, if we increase this square, maybe, you know, well, actually, no, it goes way off there to be getting to a 40. So this is roughly how the sizing works. And even though we may have items which are not quite the same shape and so forth, we can still say, you know, roughly, it's sort of like this. So this triangle, probably roughly an 8. As well, the circle, probably roughly an 8 as well. This circle over here, somewhere between a 20 and a 40. And if you want to err on the side of safety, call it a 40. Okay, so we do relative sizing of these shapes. And this could be anything. So it could be, well, the features. So let's look at that. So we take our features in this top right to bottom left sequence, and we put them onto a wall. And there we are. And now we have our group of people who are having the kind of experience and potential input and can provide value in thinking about how much time or cost will we need for this one versus that one versus that one versus that one and so forth. So we take one of these and say, which one do we think is the smallest one? Which one do we think is quite easy to do? And we go, oh, well, looking at all of this is something we've done. And normally, you're going to pick it from somewhere here. Something that people think is not really the most difficult thing here on this MVP wall matrix. And we give that 1 and 2. Okay, now that we have a reference, it becomes a bit easier to do the rest. So how much is this one? Well, yeah, I think it's probably about twice as difficult, but we don't have a 4, so we're just going to give it a 5. Great. And this one, well, yeah, at least 4 times, so it's about an 8. This one, it's about a 20, and now you start discussing between each other. It doesn't obviously go this fast. There's some more discussion about relative sizing, and everyone can provide input as to why they think this. So what factors into this estimation here of relative size or relative cost? If it is only like just a software-based project, these days, hosting costs are not really tremendous, so the costly thing is how much time is this going to take of people to try and figure out or do? And we need to think of those 3 aspects of business risk and complexity and uncertainty. Complexity and effort. So if something is going to be a lot of effort, it's going to be big. But if it's also something we've never done before, we're also going to give it quite a big number because it might take a long time. So how scared are we of this thing? But if it's involving quite a bit of engineering, let's say physical engineering or whatever the case may be, circuit boards or whatever, then there may be significant material costs involved as well. So you need to discuss amongst each other, what are we going to try and factor into these relative sizes / costing. And the more it's like a software kind of project with people and trying to do software, the more this is like a proxy for time really. But if it's involving some pretty hectic engineering and so forth, physical engineering where you may have to put up, pay for expensive material and doing an experiment is expensive, especially if you have to throw it away and all this kind of stuff. You need to factor in some aspects of those, and this then becomes much more a proxy for cost than it is a proxy for time, which is then a proxy for cost. But you need to discuss and agree what makes most sense in your circumstances. But you can still use this relative scale to think about relative time and cost. Okay, so we continue sizing this backlog, this product backlog. And maybe this one is a huge one, very scared of this one, maybe another 40 and another 40 over here and a 20 and a 40 and maybe there's even more. So we're going to have this whole thing sized, and we're going to get to a total. So once we've done this, we can add up all of these numbers, and then we can get to, let's say, a total of 500. Now this number currently is meaningless. It's just a whole bunch of relative sizes added up together to give you 500. So how can we go from this to time and cost? Well, what we do is we do the following. We say, if we look at this whole feature backlog over here, what kind of team would we need? Consisting of what kind of skills? So what is the smallest kind of team that we can put together that could work their way through this whole feature backlog and try to actually create this solution? Well, we would have an audio engineer, let's say, and a graphics engineer, graphics designer, or software developers, and whatever the case may be, maybe power experts, whatever the case may be, whatever this kind of backlog kind of looks like. And what is let's say, the smallest group of people we can get together that could work their way through this feature backlog? And then we go, okay, well, how much would a group like this cost every 2 weeks? Roughly, what would they cost every 2 weeks? Well, if we look at the skills involved and so forth, let's say we think it'll cost What should we say? Let's say $50,000 every 2 weeks, whatever the case may be. This is not so relevant what the exact amount is. So let's say $50,000 every 2 weeks. And factoring into this cost, again, as stated before, it may only be the actual cost to these people. And maybe, if you want to factor in the cost of an office and so forth and so forth. But if it also is involving engineering aspects, you need to try and figure out a proxy for what kind of material might they be using and roughly what would it cost for these people to be working through this kind of feature backlog for 2 weeks at a time. And then we say, okay, if that is our minimum team that could work through this feature backlog, how much could they achieve in 2 weeks, do we think? So here we put our 2-week time box and we take the smallest ones that we have on the board. So, could a team like this possibly do this one in 2 weeks? Yeah, yes, they could. Could they do this one as well? This number 3? Yes. 2 and 3, and could they do this one as well? Yes. And so forth. So we pick items, and let's say that, just to make the maths easy, please, that let's say this one gets to a total of 50. So a team like this can do so much work, and if we add up all the story points, then it looks like about 50 story points every iteration. So if we can do 50 story points every iteration, well, we have 500 of these story points. So it might take us then 500 divided by 50 equal to roughly 10 of these 2-week iterations to work our way through this whole thing. Okay, so we might need then 10 of these 2-week iterations to work our way through this whole backlog. And what we've done now is we've derived basically from this number time and cost. And we do it by saying how much could a team like this do in a time box like this. And then we're using this total and the relative size of the work that they can do in a time box, divide it, and that gives us our view on roughly 10 iterations needed. And because it's $50,000 per iteration, that also means that the cost will be roughly $500,000. Okay, so this is not exact. And the rule of thumb that I normally use, which has been successful in the past, is that if you have a team that has a reasonable understanding of this business space, and they've also worked in this technology stack before, so you have people that have reasonable experience in both the technology as well as the business space, then I would go plus minus 10%. Plus minus 10%. So just let me write that somewhere else a bit more clearer. So we're saying that we have a total of 500 points divided by 50, which gives us roughly 10 iterations. But we're going to say plus minus 10%. So we're actually having somewhere between 9 and 11 of these 2-week iterations. And because we have $50,000 per iteration, it's going to be roughly, what is the total for this would be $500,000 plus minus 10%, again, gives us roughly 450K. Let me try that again. 450K all the way through to 550K. Okay, my writing is terrible. I'll put this on we're going to do it in the slides afterwards, just to recap again. So plus minus 10%. So now we have 9 to 10 of these 2-week periods, as well as roughly this budget. And when, of course, you go discuss with your financiers or whatever the case may be about budgeting, you really try and pick those numbers, because this is what it sort of looks like. There's also the instance where this is a completely new business space to your team, or you're dealing with technology that you haven't really dealt with before. It's really completely new stuff. And in that environment, I tend to go for plus minus 20%. So then it's not anymore going to be, if we say 500 divided by 50, roughly 10 iterations, plus minus 20%. We have roughly 8 to 12 of these 2-week iterations. And if this is going to be our $500,000 cost, it's going to turn out to be about 400K all the way up to about $600,000. Okay, and then again you pick these two numbers, your worst case sort of a scenario. And what we basically have here now is if we can now ask the question, if we could get something that looks sort of like this, in, let's assume it's a plus minus 10% we're giving ourselves, in between 9 to 11 of these 2-week iterations, and it's going to cost us roughly 500K, but on the outside, let's say 550K. So if we can get something like this in about this time period for about that much money.
Shall we play a game?
Exactly. Shall we play a game? So that's the question you then have to ask yourselves. Now, businesses and entrepreneurs and investors especially, and finance directors and so forth, might be going, this is not good enough. I can't let you start doing this. Because once I say yes, to this, then I know that we're going to assemble the team and then we're going to start doing these iterations and who knows how it's going to go. Maybe all the money is gone and then we don't have anything. But that's not what we do, because what we did initially is we found our angle of attack, and it was risk-based. So these top right-hand issues or features over here are the ones that really could make us fail. So when we're going to do these iterations, we're going to start here. We're not going to mess around here. We're going to start right here and tackle the most critical things first. And if we look at risk as sort of something like this, so the amplitude of the sine wave, or whatever the case may be, is an indication of risk, outstanding risk on this whole venture of ours to do this, take this first minimal viable product out to market. And because we're starting with the highest risk items in the first 2-week iterations, we are working basically to really prove feasibility as quickly as possible, the core of feasibility. And once we get sort of here, it settles down and it tends to become a bit more, just more work. Okay, so this is really the crux of where you want to determine whether we're probably going to succeed with this thing or not. And in terms of our risk value matrix, this is where we are focusing in that space. And as soon as we get past here, basically where we are is we're starting now to do these, some high value and some lower value, but importantly, lower risk items. Because when we get here, we can basically say, we can do this or we cannot do this. Okay, so if you're going to fail, you really want to sort of fail in here, and setting ourselves up in this way gives us a great way to be able to determine, whether we're going to fail and do that early, and potentially pivot in some other direction to go in that direction. And if we need to pivot again, do a slight pivot over there, but not quite pivots there anymore, which are just changing this feature to something else. But over here, you might do some quite big pivots or stop the entire thing completely. So basically, this is how we go about determining at the correct level massive force, economy of force, simplicity, and in setting us up to be able to be on the offensive and surprise, because we're not going to spend a year now investigating this. We've done enough to get a feeling of should we tackle this, or should we not tackle this, and when we start tackling it, we go for the highest risk things first. And as we work our way through them and solve them, we continue. But at any point, we can say, oh, this is not going to work because we've dealt with this highest risk item and we cannot do it. It's impossible. It's not working, or the regulator is going to shut us down, or the customer experiments we've done here is telling us this is not going to work, and so forth. So if you want to fail, if you're going to fail, you want to fail at least early. Good. So let's recap this in the slide deck.